Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous video we constructed an unambiguous version of a grammar which represents arithmetic operations. Now let us see few more grammar representing programming constructs in various general purpose programming languages. Over here the first one we are going to discuss is variable declaration. We know that in any general purpose programming language, before using a variable we need to declare them. For example, we declare int a is equal to 10 or something like that. Based on that, let us try to generate a grammar. Before writing the grammar, let us have a few assumptions. In a general purpose programming language, we will have a lot of data types. We are restricting our data type to have a simple grammar. Let us say the data type that we are allowing are integer, double and float. Let us say the name of the variable always starts with an alphabet. And it contains only alphabets and numbers, no special symbols. Declaration always terminates with a semicolon. Now we need to put these rules into a grammar. Let us try to write the grammar for the same. First, let me give a few examples. Int a1 is one declaration of a variable having integer as the data type, a1 as the name. Float f33 is an example in which the data type is taken as float, the variable name is f33 and followed by a semicolon. Double pi, here double represents the data type and pi is the name of the variable followed by a semicolon which terminates the declaration. Let us try to write the grammar. Let us take declaration as DEC as a start symbol. A declaration is a type name which is int over here, float in the next one, double in the third one. We can see that the start part of every declaration is a type. Over here it is int, float and double. Type is followed by the name, which would be followed by the end symbol over here, which is a semicolon termination. Now let us try to expand the non-terminal type, name and end. What all values type can take? Based on assumption, it is int, float and double. Now we need to write the recursive rule for name. We know that name always starts with an alphabet and it can contain alphabet or a number. So I will write a recursive rule to extend name. A name is a name followed by an alphabet or a name followed by a number or simply an alphabet. Over here, remember that we are not writing the rule name can be a number because we can never have any variable with just number because we are not allowing the start of the variable name to be a number. End symbol is simply a semicolon. We have constructed a grammar. Now let us try to parse the string that we wrote here using this grammar. The first string was int a1 semicolon. Declaration would be the root of the tree because it is the start symbol. It has three components. The first one is type. Second one is name Third one is end. From type, we want int because the variable a1 is integer type. From name, we have to construct the string a1. To construct one, we need the production name followed by number. To produce a, we have to replace name with an alphabet. We have constructed the tree. Now let us try to write the terminal strings. Int is already constructed. Alphabet has to be a. Number has to be 1. And the end symbol has to be. And the end symbol has to be the semicolon. We can see that the yield of this parse tree is int followed by a followed by 1 followed by semicolon, which is the expected string. Let us try to draw the parse tree for the second string, which is float f33 semicolon. Again, the tree would be similar. The root of the tree would be DEC, that is declaration. It will have a type, a name, and an end symbol. The type would be different. Over here, the type is float. Name has to be a name followed by number. But over here, there are two numbers, that is 3 and 3. Once again, we'll have to use the same production. The first name has to be an alphabet, which is over here F. N has to be semicolon. Let us try to see the yield of this parse tree. It is generating float followed by an alphabet. For us, it has to be F. Followed by a number, which will be 3 over here. Followed by one more number, again has to be 3. Followed by the end semicolon. You will see that the yield is float f33 semicolon. So we are able to generate the required string from the constructed grammar. Now let us try to see the third string. The string was double pi semicolon. The root of the tree would be again DEC, which will have type, name, and end. Over here, the type required is double. The name contains 2 alphabets, so we will use the name contains 2 alphabets, hence we will use the alphabetic rule of the production. Name followed by alphabet. Again, we need one more alphabet, so name is an alphabet, that production would be used. The first alphabet is P, second alphabet is I, end is a semicolon. Let us try to draw the yield of this parse tree. Double followed by P followed by I followed by a semicolon, and hence we can see that our grammar is parsing the given declaration statement. From the last video, we have been writing grammar for various programming constructs. We have written a programming construct grammar for arithmetic expression. We have written one for variable declaration. From next video, we will be trying to solve more questions such as loops, if statement, etc. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.